Cambridge iGCSE Chemistry, Catalysts. We'll start with examples of catalysis from the syllabus, how catalysts work, and then briefly enzymes. Let's start with the definition of catalysis used by Cambridge iGCSE. Catalysts speed up the rate of a reaction, but are unchanged by the end of the reaction, by the reaction end. So they speed up, but are themselves unchanged overall. Let's consider an example from the syllabus. Platinum metal is found in car exhaust catalytic converters. A honeycomb structure is employed. Now, a honeycomb structure is a three-dimensional version of this 2D diagram. We've got tubular hexagons. Each of these tubes or hexagonal tubes are impregnated with platinum metal. Now, the reaction in question takes hazardous pollutant gases from the combustion of fossil fuels in the car engine. That's carbon monoxide and nitrogen 2 oxide, and converts them into atmospheric gases. Can you either work out or recall the products of that catalyzed reaction? Pause the lesson, complete the equation, come back to check and correct when you are ready. Okay, so here are the products: 2 carbon dioxides and nitrogen gas N2. Now, just to say a little bit more about the honeycomb structure, and this is the principle rather than the fact, has a high surface area to volume ratio. So that maximizes the contact between the gases and the catalytic metal. So let's move on to a second example. Vanadium 5 oxide, V2O5. Again, small pellets, because that illustrates the principle of high surface area to small volume being employed in catalysis. So vanadium 5 oxide catalyzes the conversion of sulfur dioxide into sulfur trioxide, which is the contact process in the manufacture of sulfuric acid, which is itemized in your syllabus. Pause. Can you write the equation for the conversion of sulfur dioxide into sulfur trioxide? I'm about to reveal. 2 sulfur dioxides, oxygen O2 gives us 2 sulfur trioxides, all gaseous. Please note, to be correct, the equation needed the reversible reaction symbol. So in the contact process, this is an equilibrium is reached between these 3 substances. Of course, the SO3 formed is then further reacted to form sulfuric acid. That is not the topic of our lesson. There's a separate lesson for you to view on that. Vanadium 5 oxide only catalyzes this reaction. So the general principle that this illustrates is that catalysts are specific to particular reactions. And that is true across catalysis in general. A second generalized point is that both the examples that I've shown on these 2 slides involve transition metals. So the general principle that these 2 slides illustrate, or these 2 examples illustrate, is that transition metals and their compounds act as catalysts. Catalysis is a property, distinctive property of transition metals and their compounds. How catalysts work. Catalysts work by lowering the activation energy of a reaction. Let's remind ourselves of what a reaction pathway diagram looks like. Energy, course of reaction, reactants, products. There's an energy barrier between the reactants and the products. To become products, the reactants must collide with enough energy, the activation energy. And that energy is the difference between the original energy state of the reactants and the top of the reaction pathway curve. Now, if we look at a catalyzed, the same reaction but a catalyzed reaction pathway, we'll see that the activation energy is much lower. So the catalyzed activation energy is a much smaller energy requirement than the original activation energy. That means that at any given temperature, the energy of many more particles now equals or exceeds the activation energy. So on collision, many more of those collisions as a percentage are successful per second. Hence, the rate of reaction is greatly increased by the addition of a catalyst. Biological catalysts are large molecules called enzymes. So here is our enzyme in green. The enzyme has an active site that is shaped to receive a particular substrate. Again, the orange color. The two fit geometrically. The reaction of that substrate is then catalyzed by the enzyme. As far as chemistry is concerned, the chemistry syllabus is concerned, there is one example of enzyme catalyzed reactions you need to know about, which is the anaerobic fermentation of glucose by enzymes contained in yeast. Here is the formula for glucose. Can you complete the equation for the anaerobic fermentation of that glucose molecule? Pause the lesson, complete the equation, come back to check and correct when you are ready. So to reveal, 2 molecules of ethanol and 2 molecules of carbon dioxide. That equation needs to be known in the chemistry syllabus. An important point is that unlike catalytic action, enzymatic action is affected by temperature. So factually, you are expected to know that enzyme catalyzed fermentation is stopped by temperatures above 35 Celsius. I believe the biology syllabus will give a fuller explanation of that. So you need to test yourself before moving on. So find problems in your textbook or online for which you have access to answers. Complete a number until you are confident and correct, then move on to past paper questions. If you've got any feedback, I'd be grateful for a comment or a like, or if you are so inclined, please subscribe.